Welcome to Embedded Edge with Nitin, a podcast that brings to life the stories behind today's embedded systems, technologies and products. It's the show where you'll hear from both engineers and executives on some of the most topical news and most pressing challenges in the world of embedded system design. Here's your host, Editor-in-Chief of Embedded.com, Nitin Dahad.
Hello, welcome to this edition of Embedded Edge with Nitin, in which we focus on security. With the Cyber Resilience Act set to become enforceable by law in Europe, we talked to Infineon Technologies Senior Director for IoT's Ecosystem Development, Preeti Orikemani, in which she talks about the implications of the Act, not just for Europe, but for the global supply chain, and the timeline and some of the things embedded systems developers need to be addressing now. In the second interview, I talked to Dom Rizzo, founder of the Google-backed Open Titan Secure Silicon project and now founder and CEO of zeroRISC. He talks about some of the cybersecurity challenges ahead for chip manufacturers, IoT leaders, and those involved in critical infrastructure, and how they need to plan ahead for them, and how manufacturers and embedded IoT leaders are navigating the recent cybersecurity regulations from the US and European governments. In particular, he also talks about the role of open source silicon security in protecting national security, especially during a time of ongoing chip shortages and geopolitical tensions. He'll also highlight the next round of innovation that will drive the future of open source. Now, here's a message from the Hardware Pioneers Max show in London, where EE Times and Embedded.com are media partners. Prepare to embark on an electrifying journey into the future of electronics at Hardware Pioneers Max 2024 on May the 28th and 29th, 2024 in London. With over 3,000 visitors and over 100 exhibitors joining worldwide, Hardware Pioneers Max 2024 is where you take your engineering skills to the next level. Head to the hardwarepioneers.com and use the code PARTNER50, that's PARTNER 50, to get 50% off your ticket. Okay, with that message over, let's get straight to the first interview with Preeti from Infineon Technologies. Hello, I'm talking to Preeti Orikemani, who's a Senior Director at Infineon Technologies for IoT Ecosystem Development. Hello, Preeti.
Hi, Nitin.
Tell me a little bit about your role at Infineon. That's quite broad, IoT ecosystem development, but I think you've got various responsibilities, including security, but also you sit on various boards as well.
That's correct. Thanks, Nitin. I'm working at Infineon's Connected Secure Systems division. I'm responsible for various organizations, also representing Infineon in various board, NFC Forum being one, also in Eurosmart, which is the Security Voice of Europe. I'm in the IoT committee. I'm director of IoT committee there. And my role requires me to interact regularly with policymakers within Europe, where we are providing advocacy towards technical regulations that are coming in Europe that are in development or in revision. And in the various boards, especially in NFC Forum and in FIDO Alliance, where we are looking at bringing technology for IoT. Security is a core tenet in both of these. So it kind of comes together to the core function that I fulfill within Infineon, which is driving ecosystem development for semiconductors. And you are aware, as digitalization is becoming an everyday thing for us, and semiconductors are at the heart of it. So yes. That really drives us at Infineon to make a world more secure, safe, and eco-friendly. I have passion for security for a good reason. I mean, being a mother of two, that becomes really important that we leave. It's not just a kumbaya for me. It is really a core. It's in my core that we make a world a secure place. So it's not just professionally, but personally, I feel involved whenever security is in question.
Indeed, and I think everybody I speak to in the cybersecurity or IoT security world is passionate about it and always finds it very difficult to understand why people don't take it seriously. But I think maybe with legislation, which we're going to talk about now, it might be a little bit different. So, yeah, that's what we're here to talk about today. We're going to talk a little bit about the up-and-coming Cyber Resilience Act, which is about to be put into law. But tell us a little bit about what the background and the timeline.
Yeah. So the way I see it is we have had as IoT became more and more prevalent, as we have more and more digitalized products, we have been having a lot of standards being developed. HC 303, 645 being one of them, which is hugely popular. What we have been missing is the guardrails, and EU Commission has, and I really commend the efforts from the Commission on this one, has come up with the Cyber Resilience Act. This is a very broad piece of legislation. What I mean by that is the impact is huge. And the impact is not only for products, devices which are sold within Europe, but also supplied into Europe. So if there are components, so the entire supply chain gets affected by the Cyber Resilience Act. So the Act itself states the scope is for all components and devices, hardware and software, which have digital elements, so hardware and firmware. And it excludes a few things like automotive, medical, and aviation, because there are already laws for cybersecurity around these components. But the primary goal for Cyber Resilience Act is to raise the security baseline for products, for connected products, for digital products, and to keep the tenets of EU Commission's principles around security, safety, and privacy for as Europe goes more and more in the digitalization.
I think one of the things maybe our listeners will probably do with a little bit of understanding is, although it's a European act, I think it affects I think you did say it earlier, but just to emphasize, it's a global supply chain. So it's not just about people in Europe. It's about anybody who's designing, whether around the world, for supply chains that supply any form into Europe, a digital product. But also, I think the other aspect is just, in terms of the principles, they would apply even if, you're in the US or Asia or anywhere. So maybe those two elements.
That's correct. So what would it mean for the supply chain, for the global supply chain? Cyber Resilience Act, as you would have heard in the news, is imminent. So it's going to be released and made into law. The Parliament passed it right after EU elections. We are expecting it's going to be officially released. Thereafter, as the cycle for bringing such a piece of legislation into the market and to enforce it, EU Commission is going to provide something like 36 months, which is customary. However, what I would like to emphasize for suppliers worldwide is the impact of this, right? It is imminent for all of us. When we really look at the law, it talks about if you're going to supply components within Europe, then you need to comply with Cyber Resilience Act. Either you directly do that or you provide due diligence to manufacturers who are going to do that. The consequence of this is going to be that if you have a product development life cycle of 2 years or even 3 years, then you have to start today, right?
Yeah.
To be prepared for Cyber Resilience Act, even though there will be this moving target as the standardization work goes on. But I would like to encourage all listeners of your podcast to be tuned in to what is happening around standardization with cyber resilience within Europe, because this my belief is going to become the de facto for the rest of the world. just to understand the law of scale here, if you are a component supplier, you're not supplying only into Europe. You are a global component supplier. So if there is a baseline which is raised, then you would consequently raise the baseline for everywhere else as well. So even though there might not be a similar piece of legislation outside of Europe, I do believe it would mean that the impact is there nonetheless.
And I think the other aspect of my question was, in any case, the principles, could be applied anywhere because the safety security elements are sort of baseline for anywhere. Is that right?
That's correct. So that's another aspect, which is when we are consumers of IoT, when we are consumers of devices, of digitalization, we would like to have a security in when we are using it. So the trustworthiness of the components, the trustworthiness of the devices that we bring into our homes and in our industry is an important element. It's global. It's not just for Europe. So that is one aspect which we need to be mindful of when we are developing.
And what are the consequences of not complying? I just thought, what would happen and who would get hit?
So the law itself is very strict. The consequence of non-compliance is heavy. It can go up to as much as 2.5% of your total revenue. So which is huge when you are a manufacturer, which is supplying to a broad base. So the details, of course, everyone can look up to it. Sure. But the impact itself is similar to the law that we have in UK, which is also having a legal implication of up to 10 million. We have a similar level of consequence for Europe as well.
Yeah, I think I wasn't trying to sort of scaremonger people, but I think it's useful to understand that, it's not just one of these, okay, it's just a law, but you can carry on doing what you do.
Yeah, I would like to point out here, Nitin, the previous laws around cybersecurity, they left us like the Cyber Security Act. It was more of a voluntary law.
That's what I mean.
Which is if suppliers had an application which was requiring some level of security, you had to do an evaluation and then you could apply the level of security. With Cyber Resilience Act, you rightly pointed out, it's a mandatory regulation, which the intention, the way I understand from the EU Commission, is to raise the security baseline for all devices. Either they are already covered by previous legislation, like for automotive, aviation, and medical, or they come under the preview of Cyber Resilience Act. And here I would like to point out, this law is also forward-looking. There are provisions in the law which also talk about if there is a future law, for example, for edge devices or for AI coming up, then those considerations that Cyber Resilience Act is giving has to be either upheld or extended. So it's also a piece of legislation which is not just going to happen once and that's it. It's going to be impactful also for future applications like AI.
It's foundational. I think it's providing a foundation. Okay, so for our audience, in terms of the embedded systems development, design, what are the challenges and opportunities? I think it's probably useful for them to understand what they need to be thinking about.
Yeah. So when we are developing products, when we are developing digital products, and have to comply with Cyber Resilience Act since it's a mandatory piece of law in Europe, I would be looking at three aspects, which are also a huge challenge at this point in time. But once we have conquered those challenges, and I'm very sure we would, Europe has already done this with GDPR, where it was a huge piece, it was foundational, but we were able to overcome it over the years. With CRA, we expect similarly. The three big challenges that I see is the first one, as I mentioned, is bringing in the standardization bit in place, because we do need, so the regulation path provides the guardrails, but the actual path is paved by standardization. And that standardization bit has started now. So Senelec working groups are working on it, and this is not going to be the only working group. There would be other STOs within Europe which will be involved for standardizing Cyber Resilience Act. And that is going to be very challenging, I would say, but also very important for everyone to contribute to. So if you have competence and you are bringing in digital products within Europe, you would be interested to get involved there. So that's one bit. The second is building the security foundations within your organization. So security is not granted, and the understanding of security varies a lot.
Yes.
And with the Cyber Resilience Act, it becomes really important for also device makers, SMEs, small, medium-sized enterprises, to build some basic security know-how and or to go and outsource it. So there is immense security know-how in the industry. Infineon being, so I belong to the Connected Secure Systems division. We have been working in the ID payment and IoT devices security for years now, also industrial IoT for years now. So go out and call for security expertise is going to be challenging on one side, but also provides opportunity. The third bit is then really putting in those security outcomes into your devices. And for that, I would like to encourage everyone to reach out to a company like ours. Infineon provides security products. We have been, as I mentioned, been delivering our Secura products, Optiga, as well as PSOC products and Semper products, which have been security hardened and which allow devices and components to bring the security outcomes which Cyber Resilience Act would require.
Well, Preeti, thank you very much.
Thank you, Nitin.
I'm talking to Dom Rizzo, the founder of the Google-backed OpenTitan Secure Silicon project and also founder and CEO of zeroRISC. Dom, hello.
Hi, Nitin. Thanks so much for having me today.
Dom, before we launch into some of the security challenges and open source silicon security, let's just get a little flavor of what you've been up to and where you are with zeroRISC.
Sure, absolutely. So in the last year, what we've done is we've actually helped with the coalition of all the other partners that are in the OpenTitan project, Google, Seagate, Western Digital, Revos, Low Risk in particular. We've actually gotten the first chip out to a production ready state, right? So we've actually got chips.
Sorry, just go back one and just OpenTitan, the concept is?
OpenTitan, yes. So sorry, OpenTitan, the concept is to really create a secure by default kind of open source ecosystem of silicon IP blocks and then produce branded sort of cohesive top level designs from those. And the first of those is called Earl Grey. That's the chip I was referring to earlier. So that in the last year, it took us 5 years and quite a bit of investment. And that investment has turned into a real chip, something that is useful as a root of trust or as a platform root of trust or as a hardware multi-factor authentication device, those kinds of secure microcontroller applications. So that's where we are today. We've got that in hand. It's going into mass production at the end of the year. And we at zeroRISC, what we're doing is we're really focused on getting that out into the open marketplace. We've made it available today on our website through a really kind of a small early access program. And I think what you'll see in the future is we make that much more broadly available, in the next 6 months or so.
Okay, good. So that's a great starting point. And tell us a little bit about, now, there's lots of things coming in, in terms of regulation and you've got various acts around the world. What are the biggest cybersecurity challenges for chip manufacturers and those in IoT and critical infrastructure? And what kind of things can they should they be looking out for?
Well, I think there's a real spectrum of challenges here. A lot of it comes down to adoption. So in the first kind of level, there's getting the security into the chips themselves, right? That has traditionally been quite an expensive proposition. It's pretty specialized knowledge. It's quite challenging to do, which is where I really see things like open source silicon having at least a large initial impact, because the cost to integrate is inherently lower. But then kind of moving beyond that, you say, well, in a few years, we'll have a whole ecosystem of secure by default silicon ready for integration into platforms. Well, then you have a deployment problem, right? It's great to bake this stuff in, and there's kind of a smooth path of you bake it in by default starting now, and so it's available when you need it. And then there's kind of this more rocky road, which we're unfortunately seeing happen today, which is these rip and replace operations. We realize that something is terribly broken at the very, very start in the silicon. It's not like you can't ship the chips back to the fab and have them make just one more editing pass, just one more mask, right? And then
you can't do over-the-air updates either. You can't even
can't do over-the-air updates. That's right. So so one of the real challenges is getting high quality silicon security baked in from the very beginning, because you have to really think about it, a long ways ahead of time.
Okay, I think that is something we've been writing about and talking about for a while in terms of thinking about it right from the beginning. Tell us a little bit about the role of open source silicon security, because open source, people might think, oh, how can that be secure? But I think at the same time, there's a reason why it does make it. There's arguments for having that open source silicon security.
Yeah, there's a bunch of different axes there to consider things on. So I think the first one I would point to is the inherently lower cost and kind of permissive licensing of open source silicon designs like OpenTitan really can act as a great facilitator of adoption. So it kind of enables the potential for a Cambrian explosion of secure silicon to really just become the default, right? It's high quality, it's low cost. What's the reason not to adopt it, right? It provides a ton of value. It provides a ton of manageability. It really enables a more safe and secure world. Now, on the flip side, you get people who say, well, it's open source, so it can't be more secure because it's not hiding all the countermeasures and all that. I don't really agree with that. I don't think the security of a end product is really a function of whether it's open or closed. I mean, we use the libraries like OpenSSL, Boring SSL. It's sort of assumed the default in the cryptography world that of course your implementation is open source, because how else are you going to be able to know if it's working correctly or not, right? And so what makes something secure or not is not whether it's open or closed. Reverse engineering and silicon reverse engineering is a really advanced state. It's inexpensive. It's fairly commoditized. What makes something secure is a focus on security from the start and really baking it into the design, really thinking ahead and saying, what are the right algorithms to support? What are the right countermeasures to put in there? What are the best practices for a secure silicon design? Open closed is kind of fairly immaterial. And I think there's actually a really interesting point here. Is one thing that we learned over the course of developing OpenTitan, developing this first Earl Grey, and then the Darjeeling designs, is that being in the open puts more scrutiny on us. So there's a social pressure to not make mistakes, to do things the right way. But because we were targeting relatively high levels of common criteria certification, we don't actually get points. It's a point basis. We don't get the points for having the design knowledge be closed or proprietary. So what that's done is it's forced us to, and this is not a bad thing at all. It's forced us to build more inherent security in there to ensure that there are no breaks in the design, right? So there's some really kind of counterintuitive, if you want to make commercially successful open source silicon, there are some counterintuitive pressures at play that actually, in a sense, force you to make a more secure design.
And you talked about being out and talking to customers. What's the feedback you're getting from customers on some of the things you're doing with this with Earl Grey, I guess?
Well, they love the price point. They think of it as a fundamental capability, right? They're like, this is a foundational capability, right? We need to understand how to use this, how to leverage this. The fact is that there's kind of a growing awareness that the most persistent, pernicious threats are coming in. They're coming in below the operating system level, or they're happening at the operating system level, and they're becoming kind of dynamically adaptive, where they're modifying the nature of the attack, hiding indicators of compromise midstream, things like that, right? And so what we're seeing is a growing awareness of customers of something like the OpenTight neural gray design, or in the future, these Darjeeling integrated platform root of trust, chip root of trust designs. It gives you the ability to get back to good with a reset, with a single sign command, with relatively straightforward kind of management techniques, right? And so that's like a super important capability. The fact that even if the fact that we are dealing with a class of attacks today where you can't really be confident that you've actually managed to evict the attacker from the device, that's very concerning, right? Because you'd much rather have a little bit of downtime where you're resetting the thing and you've got the cryptographic guarantees that the box is coming back up in a good state than having to rip out and replace the entire box, which is actually something we're starting to see of we can't fix it in the field. It has to be replaced. Infinitely more expensive.
Okay. Now I have to ask this. So you said Earl Grey and you talked about Darjeeling. Tell us a little bit about the differences.
Right. So the Earl Grey design is a discrete chip. It's a small, I want to say 5 by 5 millimeter design. That is something that you would include on you'd integrate into a larger platform as a discrete chip, right? Now it's capable of serving as a platform root of trust. It's capable of serving as, it's very well coupled to IoT devices as an IoT root of trust, or even a IoT processor.
So it could sit on a system on module, for example. It could sit on a system on module.
It could absolutely sit on a system in module. You could integrate it into something like, you can't see it over the audio, but like a security key, a U2F second factor device. And it's something that's available today, right? Well-known principles, but all completely open. The design is completely, the digital design is completely open and available on the website. Now, Darjeeling is, we talk about OpenTitan as a root of trust, but really OpenTitan is this ecosystem of high quality IP blocks. So what we've done in the last year is we've actually taken what Earl Grey was composed of, and we've taken those individual components, we've remixed them, re-put them together to serve as a SoC or a chiplet root of trust. And Revos is actually, and this is publicly available information on their website, they've actually adopted the OpenTitan Darjeeling design as the root of trust for all of their individual chiplets as well. Okay. So we've it took us 5 years to make the first top level design. It took us a year to make the second. So that's kind of there's a bit of an open source flywheel that you have to get spun up. But once it's spun up, once the number of parties engaged are at a sufficient level, thing takes on a life of its own and just organically starts to see adoption and evolution.
Just as a side note, so obviously chiplets are the in thing right now, but one of the issues is around expense and interoperability. So I guess these are UCIe standard, and they are lower cost than you might sort of look at if you're sort of trying to build these complex chiplets.
Yeah, I think that cost probably, I'm not a chiplet expert. I shouldn't speculate too much, but I suspect a lot of that comes from yield. But I think not only, so interoperability is definitely a thing. A lot of that takes place in the analog realm. You really, really want high speed links between these devices. So we're not doing much of that. Now, the one thing I will say, and I don't know how broadly understood this is as an issue, but when you disaggregate monolithic silicon, you break it apart, turn it into chiplets, which have a ton of advantages. You really need to think about security as well, because you're inherently changing the threat surface of it. It's a lot harder to probe a running chip than it is the substrate that's interconnecting it, right?
Exactly.
And so it really gives me a lot of confidence that we're seeing folks like Revos, who are very well established in the RISC-V ecosystem, taking something like that so seriously from the beginning and really understanding that, there is a way to get the advantages of chiplets and yet still end up with an even more secure system. And I suspect more people will start moving down that road when it's understood that, the interoperability, it's not just about the kind of transport, the kind of digital, the analog layers, it's actually the logical security as well. You need to have a way to be able to combine these chiplets securely and sort of have them, maybe they're not physically all combined, but they have to be sort of in a security logical sense, one device.
Great. Let's look at what's coming next. What's the next round of innovation for open source silicon? I know it's not like you're looking at speeds and feeds, but you're looking at very real stuff. Tell me what's coming next.
Yeah, I think that's right. I think you'll see with a project like OpenTitan or others like it, where there's only so many ways to slice and dice the silicon root of trust. There are a lot of different places there, but we've already built that basic ecosystem of blocks, right? And it's not clear that there needs to be a lot more than what already exists today. So I think what you'll see as these projects evolve, they will move not so much, as you said, speeds and feeds, not so much up some kind of performance roadmap, but much more kind of laterally and into the, okay, what does it look like to kind of build a framework that's secure by default, that has the silicon security baked in, but has the ability to connect not just open source IP, but proprietary IP as well, right? These two things are not inherently in conflict. And I think that you'll see a lot more focus on the tooling, on the integration of these, the open source root of trust into larger scale designs. But I don't really see open source silicon. It takes just so much capital investment to actually develop a credible, commercially relevant, like large scale, out of order, 64-bit, whatever, right? So I think we're going to see a little bit more lateral movement and more practical innovation of, well, how do we make this stuff work with all the different foundries? How do we build these digital designs so they're relatively easy to integrate regardless of what node you're working on? Things like that is where I see it going.
That sounds like the message you want to end on. Is there anything else you want to say to our listeners? Or
no, I mean, I think we're in a really, really interesting position. We're kind of right on the precipice of wide scale commercial adoption of open source silicon. So happy to have been played some small part in that. And I'm really, really excited to see how this stuff moves forward.
Well, Dom, thank you very much.
Absolutely.
So that brings us to the end of this episode. That was Embedded Edge with Nitin, and I'm Nitin Dahad. Thanks for listening, and see you next time.